White Rose follow an approach called the CPA approach, and you may have heard the words concrete, pictorial and abstract, maybe not, but that's, if you hear the CPA approach mentioned, that's what it means. And it's moving through from the concrete, where you actually have physical resources to pick up, through to using pictures, and then finally onto the what we know as the abstract. Now, I don't know about any of you sitting there, but when I learned maths and did maths at school, we went straight to abstract. We didn't have concrete or pictorial. And even when I started in year one, we wouldn't have, it would be very much a focus on the abstract way of teaching, and quite a lot of rote learning. So it has moved, and in a good way, because it really helps the children have a much deeper understanding. So you can just see cubes are used there, then the pictorial, and that's using what we call a bar model, and that will be explained later, and then on to the abstract, where you have what we call a number sentence. And then we have, you may also have heard the term four operations being used, and that's what we will work through this evening. So we have addition, subtraction, multiplication and division, and each of us will work through the four operations. So we'll go through addition from reception right up to year 3, and then so on with subtraction and multiplication. And you can hopefully then see the progression and how each year builds on the previous year's learning, all the time using the concrete resources until the children come to a point where they are confident and able to understand and use the abstract. So that's that. And then this is the calculation guidance, just to remind me really to tell you that it was emailed today by Mrs. Baptiste. So that's a document that we have put together using the White Rose. The White Rose document itself is very long, so we've picked out just some parts that we feel would be of use to you, so that you can see how we teach maths, and would explain some terminology that you might not be familiar with. So it's definitely worth your while looking at that. We have reduced it to about 20 pages, so obviously it doesn't include everything, but it gives you an idea. And then this is just something that you may find useful. Again, the one on the left is just a 1-minute app that White Rose have produced, and it's free to download. Mrs. Baptiste, I think, sent the link, or sent it in the newsletter at the weekend. So that's really good. It literally is just a minute. It goes through lots of different, you can see there, addition, subtraction, and also if a child can't answer, it has an opportunity to click hint, and then it will give a hint, and one of the hints uses some of the resources that we use in class for teaching. So it's well worthwhile downloading it onto your phone and, you know, allowing your children to use it. It is aimed at Key Stage 1, but it is very useful just to, you know, supports children's mental math skills. On the right hand side, it's times tables rock stars, and that's, we subscribe to that. The children in year 3 and coming on to year 2 now would be familiar with it. But again, it's a very useful resource to practice the times tables. And your children will have a login. If they don't use it, then I would encourage you to, you know, try and get them to use it, so that they are using their skills in a way that's fun, and they gain points, and they can buy things in the virtual shop. So they're just two different, I mean, there are lots of things on the internet that you could use, but there are two that we thought would be worth mentioning. Okay, so that's really all I'm going to say to start us off.
In reception, obviously it is the starting point of introducing maths as well. Obviously they're doing lots of things in nursery as well, so it's very more concrete. So we don't see as much abstract, but it obviously does develop, so they are prepared for year 1. So lots of it would be during their play as well. So it could be playing with toys and cars, all sorts of things, and we say, if there's 2 cars here and there's another 3 here, how many are there all together? So we try and use those types of language. There's more language up here, so we've got more, we've got all together, we've got grouping, and we've got combine as well. As the year progresses, we introduce a 5 frame, which is this one here. Okay, and you can see that we've got 2 yellow and 3 red. How many are there all together? And it develops as well, because you might have seen these before. They are Numicon, and we use it throughout the school up to just throughout the whole school, don't we? Yeah. So as well, and we've got the part-to-part whole, so you can see 2 and 3 is 5 as well. It moves on to the 10 frame. So yet again, we're still using the same resources, and then eventually we do start writing number sentences as well, which we have started doing, but it is very early stages yet, and it's just getting a real complete understanding of addition. And then finally as well, it'll be more the summer term, we introduce the number bonds as well. You can see we've got 9 and 1 makes 10, 8 and 2, 7 and 3, so on. But that is the first introduction of addition.
In year 1, here we have again the 10s frame. Chris talked about the 5 frame and the 10 frame in reception, and so we would use it. I'll just give an example like this. So the number sentence would be 6 add 5 is what? So the children would put out the 6 counters, and the counters are double-sided, as in the colours. There's one side is yellow, one side is red, and then they would add on 5 more. And we would also use that to use it for word problems. So there are 6 cars in the car park, 5 more drive in. How many do we have all together? And that use of language from very early on from reception is so important. As well as that, number lines, numicon and cubes are used for addition. The idea it's this would build on children being able to add mentally. So for example, 6 add 5. If we think about adding, we automatically think, well, 6 and 4 more makes 10, and then 1 more makes 11. Okay, so that's what it's leading on to, that they will very quickly be able to see, well, that's 10, and then they can add on the extra ones. Here at the bottom right, we have what we call 10s and 1s. It used to be called units, they're called 1s. And this is just using larger numbers, so 12 add 5, and the children would put out 12, then they would put out 5 more, and then they would count 12, 13, 14, 15, 16, 17. I'm glad I got that answer right, because I didn't. They also, as I said, we would relate it to number problems, so that they're getting used to seeing that it's not just a written calculation, but that they are thinking in terms of words around it. And then we have here, moving on to the pictorial and then the abstract.
Can you push it down a little bit?
Down this way, yeah?
Yeah.
Okay. And this is what's called a part whole model. So the whole is the 11. The parts are here, the 6 plus 5. So this could be used, so the whole could be left empty, and then you'd know, well, I'd need to add the 6 and 5 to make the 11. Equally, it can be used for subtraction, because one of the parts could be empty, and then 11 take away 6 will be 5. Also, we make sure that the children are very secure with the understanding of using the inverse, so that they know from an early age that the inverse of addition is subtraction, so that they can see the link between the two. Down here we have a bar model, and the same idea. You can see the numbers are the same, but we filled them in just to show you now. But one part would be empty for the children to add the numbers together in this case. If we're looking at addition. So they're part whole models, and just with the drawing we drew them, quite quickly, but we would have them drawn so that the children would see that the 6 and 5 are very close together, but if there's a larger number and a smaller, that they would see, well, that part is bigger. It won't be an exact drawing, but it will show that number is bigger. And then leading on here to the abstract, and we have a missing number sentence, and then the children work it out. So that's the way we would lead through addition, leading on from what they had covered in reception. And I think that, and also I did mention about number lines, using number lines and also number tracks to count on. So they would find the number 6 on the number line or the number track, and then they would count on 5 more. So that is, I'm just double checking Mrs. Duffy's notes. But another thing I will just mention, the importance, Chris mentioned it, about number bonds. Number bonds are, so Chris gave the example of the number 10, so 7 and 3 make 10. But it's not just the number 10, we would be looking that they would be able to quickly know, well, the number 7, 5 and what would make 7. the number 6, 3 and what would make 6. So the bonds for the numbers that they can easily see the two numbers that would make another number.
Let us start with concrete addition in year 2. I've started with the 2-digit plus 2-digit number. At the beginning of year 2, we focus quite heavily on place values, so they have an understanding of what 2-digit numbers are made up of. So I just put a little example here of 22, breaks down as 20 and 2, and for 31, 30 add 1. Here is an example of a place value mat. We would use these so the children can come and take the place value counters. So here we can see they've taken the first number, 20 and 2 ones, and then they are adding on the second digit number, 2-digit number, 31, 3 tens and 1. So that's quite an important part for them to be able to partition the numbers equally. And then they would eventually be able to bring that down and look at how many tens I've got, how many ones, combine it together to work out their answer. So that's an example of concrete with place value counters. I've also got one here with base 10. The children are more familiar with the term tens and ones, 10 stick being the orange, the yellow stick, and the red ones. So here is the 2-digit plus 2-digit question. 33, 10, 20, 30, 1, 2, 3, and we're adding on 2 tens and a 1 from my 21. Again, it's the same concept, but we would start thinking about adding the ones together first. This will start to make more sense as they move through the year 2 curriculum, getting ready for year 3, where we start with the ones first. Lots of children have the tendency to count the tens, but really it's thinking about it in a different way. So we add those numbers together, 54. So that is the 2 concrete ways. We do use Numicon. What other things are there? Cubes, number tracks as well, but that's just 2 examples. Moving forward to pictorial, this is how the children would first start to present it in their books from using the concrete resources. So again, they'd have a 2-digit plus 2-digit number, and they would literally draw the tens and ones mat like that into their books and present it as tens and ones, bringing it down. Eventually, we will start to move to the abstract. So here you can see that I've circled the ones in red. That means they need to add the ones together, 5 and 2 making 7. We underline the tens number just to make sure they really know the difference between their tens and ones, adding the tens together and then adding the 2 totals together to find their answer. So that would be abstract in year 2.
As you can see from the board, we then start with an abstract number sentence that we then turn into a concrete piece for the children. So 264, the children will get their counters, they'll make their 200, they'll make their 60, and they'll make their 4. They'll then make their 100, they'll make their 70, and they'll make their 3. Sorry, I haven't got enough ones at the ready. But then we get to do some fancy things. So, again, working from the concrete, so the children who need to see it this way, some children, when they get to year 3, are ready to move on, so they don't need to start with the concrete, but we do often get them to do the practical work as well, so that everybody can really solidify their knowledge. So you have our 200s, our 100, which they then group together, and they will then write down their 300s. They will work through their 10s, and they will find out that they have more than a 10 there. So they will then see that that's 130. And they will have their 7 ones. And then they'll realise that they can't have 130 in there. And we spend a lot of time talking about what happens when you end up with more than 10 in any one of the place value places. And then we start introducing the word of exchange. So we take away our 10 groups of 10 and we swap it for 100. And it is like this in the classroom, and you can imagine how many counters end up on the floor. And how much tidying up time there is. So, again, we then teach the children that 100 moves into the next space so that they can then see where those extra digits come from. And that's really important for when they move on. So when we first start this, we'll start with that particular way of working. Then, once they get secure with that, we swap it around just to make it fun for them. Because obviously when you're adding up in your head, you work from the biggest numbers down. When you're working in abstract maths, you work from the smallest numbers up. So again, we'll then start with our 7, with our counters on our board, and then we'll start by 7. Then we'll exchange as we go up, moving over, and then counting our hundreds last. So they get to do both, because the mental maths going on to year 4 upwards is as important as being able to do the written calculations in year 3 and so on. So we then have our pictorial working out, which exactly the same as in the previous years, where you then have your drawings, and lots of children love this because it means they get to draw all over their maths book. And so there they are with their 100 squares. I've got my 200 squares, I've got my 100 square, and they get off with their 6. 1, 2, 3, 4, 5, 6. See, all these counting skills. 1, 2, 3, 4, 5, 6, 7. And then they can actually see that they can swap their 3 with their number bonds to make their 7 there, and then they can stick it straight in to their square. And that's what they then do. They start drawing to show what they're understanding. Is everybody happy with that? There's a few nods in there, that's good. And then we move on to our more abstract, where we then have our question where we break down the numbers into their values, and then they add up each part 7. They get to their 130. They already know that they keep their 30 there. They then add on their extra 100, so they end up with their 400 at the bottom. Okay, and then they end up with their 400 as